Hey guys, so to get you all started on PA4, in this video I'm going to talk about two functions that are going to be really important to you, setjmp and longjmp. I know these functions can be a little confusing at first, but once you understand how they work, it's really not that bad. So the main idea behind setjmp and longjmp is that they let us save a specific point in our code during execution. So they let us save a specific point in our code during execution, and then they let us return to that point later. That's the main idea behind what these two functions are for. So it's basically like a bookmark. Right? When you're reading and you want to save a point in your book, you put a bookmark there, and then you can return to it later. It's the same idea. So setjmp is the one that's in charge of placing the bookmark, and longjmp is in charge of going to where the bookmark was saved. Okay? So, these functions, when you call them, they look something like this. You have setjmp, and it takes in this env variable, and then you have longjmp, and it takes in this env variable and this t variable. So let's talk about what these are. Okay. So first let's start with env, which is the most important one. If we look at the type of env, it says in the code, you'll see that it's a jump buff type. Okay. For our purposes, this is basically the bookmark. Right? So what it does is it saves two main things that we care about. First, it saves our position in the code. The code. So basically, like what line of code we're at. Code. Okay. And if you remember from your days of CSE 30, this is also known as the PC, or the program counter. Okay? And then second, it saves our position in the stack. In the stack. And again, from CSE 30, this is called the SP, or stack pointer. Okay, Cool. So those are the two things that it saves. It saves a lot more stuff actually, but these are the two that we care about. And then setjmp overwrites env, the env variable, with the current PC and SP, the current program counter, so the current position in the code, and the current position in the stack, so the current stack pointer. That's what setjmp does. And then longjmp replaces whatever program counter and stack pointer we have. Stack pointer with the ones that were saved. With the saved ones in this environment variable. Env. Okay. Basically, it jumps to those positions in the code and the stack. Okay. Cool. So that's what env is. Now I'll hold off T for a little bit. What do these functions actually return? Well, longjmp doesn't actually return at all, right? Doesn't return. Because it jumps to another point in the code before it gets the chance to return. Before it hits that return statement, it'll replace the program counter, and so it'll jump to somewhere else. Jumps. Into code. And this should look sort of familiar because it's exactly like what restore context used to do. Restore context. And restore context is back from PA1. So I encourage you to look back at your PA1 code so you remember how those worked and how you use them, because it's very, very similar. Okay. And then setjmp actually returns twice. Again, this shouldn't come as too much of a surprise because it's kind of like how save context returned twice. So the first time is the first time we call it, which is when we save our current program counter and stack pointer to this env variable, to our environment. And then here, this first time, setjmp returns 0. Okay. And then the second time, is when we jump back to it from a long jump. And jump back to it, back to setjmp. from a long jump. And again, if you're kind of confused about how this like returning once, returning twice, returning 0 times goes, I encourage you to go back to PA1. Maybe look at the video I made for PA1, and I explain in a little bit more detail how that works there. Back from a long jump. Okay, and if we remember how long jump looks, it takes in the environment that we're going to jump to and this t. So here, the second time that set jump returns, set jump returns t. This t. The t that was passed in to long jump returns t. The parameter for long jump. So when we call long jump and we give it a t, that's the t that set jump is going to return once we jump back to it, right? So what's really important here, a lot of students wonder, well, what should I make this t? The most important thing is that you make it not equal to 0, right? Because this first time, set jump is going to return 0. So by making it not equal to 0, you can distinguish between the 2 times that set jump returns. Just like we do with other things like fork. Distinguish between the 2 returns. Now, besides not equal to 0, should you make it like 1 or 5 or 7 or 10 or whatever? That's up to you. For now, you can keep it as 1. Later, if you want to add some logic according to the return value, like if it is a 1, then it means something, and if it's a 2, it means some different thing, you can do that. But for now, just differentiating between the 2 times is the most important part. Adding additional logic based on the return value is really up to you. And you don't need to really do that for this assignment. But you can if you want to. Okay, so let's, the last thing I'm going to do is go through an example of these 2 functions. If one wants to cooperate with me, there we go. Okay, great. So we have jump. We have our env, and then let's have our main. And main is really simple. It just goes if set jump env is equal to 0. So this is the first time, right? Remember, because the first time set jump returns, it returns 0. Then call foo with 5. Otherwise, and this is the second time that set jump returns, right? If it's not a 0, that means we long jump back to it. We're going to call bar with 2. Okay, so let's write those 2 functions. We have foo, and it takes in an int. Let's call it Z. And foo just declares a local variable. Okay. And then maybe it prints x plus c, silly function. Okay. And then, this is the interesting part, it long jumps. So, okay, it'll long jump. Oh no, let me just get rid of this real quick. Okay, whatever. Okay, to wherever env was saved. Okay. env. Let me get rid of that before I confuse people. Okay, so it long jumps to env, and then let's give t a value of 7 so that you guys see how that works. Alright, and then bar is another silly function. It takes in another int. Let's call it w. I'm going to call them different things so that you guys can see the difference, but I could call it z again because it's on a different scope. And then it has a local variable. Let's call it y. Initialize that to 3. And we're almost done here. Let's print y minus w. And that's all we need to do. Okay. So, what does this function do? When you're debugging your code or you're figuring out how to design your code, especially for this assignment, you want to always draw your stack. It's going to be super important that you do. Alright, so we draw our stack, and our stack always starts with main. Right? Okay. And main can have local variables and stuff, but right now it doesn't, but let's just give it some stack space. And the first thing we do in main is call setjmp. So remember what setjmp does is save the current stack pointer, which is here at the top of the stack. So that's going to be env.sp. That's what it's going to be saved to, and it also saves, so that's our location in the stack, and it also saves our location in the code, which is this line of code right here. So that's going to be env.programCounter. Okay, cool. That's what setjmp does, and because this is the first time we call setjmp, it's going to return 0. Because we return 0, we're going to call foo. So we go down here, see what foo does. Foo has a parameter z, and we are setting it equal to 5 because that's what we passed into foo. And it also has a local variable x, and these things go in the stack, and it's initialized to 2. So this here is foo. Foo. Okay, and so our stack is now up here. So our stack pointer, Jesus, there we go, is pointing here. And our program counter, so let's assume we set x to 2, then we print x plus c, and then we call long jump. So our program counter is here, because we're calling long jump. Now what longjmp is going to do is it's going to set our stack pointer to env stack pointer. So no, get it here. Okay. I was wondering when that was going to pop up. Okay. So it's going to set the stack pointer to be pointing to env stack pointer. And it's going to set the program counter to be pointing to env's program counter all the way up here. Okay, and that basically jumps us back to this point in the code and this point in the stack. So if we move up a little, okay, and now setjmp is going to return 7 because 7 is what we passed in to longjmp. That's what I mean by it returns what was passed into longjmp, right? That was t. So it'll return 7. 7 is not equal to 0. So we're going to go to bar. Now this part's really important. Bar takes in a w. This w is going to overwrite this z because at this point this is now bar. Right, and so we're going to save w, and I don't remember, w's 2, because we call bar with an argument of 2. Okay, so that's 2. And then it's going to overwrite x with the new local variable y. That is an ugly y. Let's try that again. There we go. And it's going to initialize that to 3. Okay, to 3. Cool. And then it'll go ahead, print y minus w, and then we'll return. Okay, but the important part was that we overwrote the foo's stack frame, and that's because our stack pointer jumped back to main. So it was as though we hadn't called the foo. So we overrode that part. Okay, so that's really important for you guys to get. Okay. Anywho, that's all you guys need to know about setjmp and longjmp. Hopefully that helped you guys understand these functions. They're really not so bad. Think of them as putting a bookmark and then jumping to that bookmark. And the two things you have to remember is that what they store is your position in the stack, which is the stack pointer. So always draw your stack. Draw your locals and draw your parameters, because those are the things that go in the stack, and you'll understand what you're overwriting and what you're not overwriting. And they save your position in the code. So also make a note of that so that you know where you're jumping to in the different points of your code. Okay, cool. That's it for now.